All right, guys, May 5th today. We're doing section 10.8, last section in chapter 10, and then we only have 2 chapters left. We're getting there, you guys. So we should be good at writing equations, is what they're saying here, written equations of lines and things like that. Today we're going to focus on how do we write an equation of a circle or graph the circle from a given equation, okay? And so compound locus, a locus is just a set of points that satisfy a given condition. And that's how we define a circle typically, so that's not that big a deal. Here's what you have to have down. So the standard form of the equation of a circle. So if you're given a circle that has a center of hk, x minus h squared plus y minus k squared, so your center hk ends up being right here, equals r squared, and of course r represents the length of the radius, okay? So let's look at a specific example here. So I've got the equation of a circle with a center at 3, negative 3, and a radius of 6. So h is 3, k is negative 3, r is 6. So there's our general formula. So x minus 3 squared, y minus negative 3, well that's going to become plus 3, isn't it? Equals 6 squared. So that's what it's going to look like in general when you're done. And that's all you have to write. There's no more simplifying. That's as good as it can get. Okay? What about this one? So now we have to locate the center. Looks to me like the center is at 1, 3, if you look at the diagram. And the radius looks like 2 units long. So center 1, 3, radius 2. First thing we need to locate. So h is 1, k is 3, r is 2. There's your general equation. 1's going to go here, 3's going to go here, 2's going to go here, and we're done. Okay? There's your equation of a circle from a graph. Okay? All right, why don't you guys give this one a shot? All right. So the center's at 2, 4. So this is going to be h, this is k, and this is r. So x minus 2 squared, so it could be this one, can't be this one, can't be this one. Y minus a negative 4, that's going to be y plus 4. Could be this one, could be this one. And 4 squared is 16. Looks like it's going to be C. Okay? How about from a picture? So the first thing we need to locate is the center. Okay, centered at 0, 3, so this is your H, this is your K. Okay, and your radius from 0, 3 to the edge, it looks like your R here is 3. Okay? Well, x minus 0 squared, that's just going to be x squared. Y minus 3 squared, so this plus 3 isn't going to work. And then 3 squared, which is 9, so it's not this one, it's going to be D. Okay? Pretty straightforward. I think you guys are going to have no issues with this. How about this one, though? Write the equation of a circle that has a center at negative 3, negative 2. Okay, so I know the h and the k, but passes through the point 1, 2, so they haven't given you the radius. Well, if you think about a circle, if I go from a center to a point on the circle, the distance between those is the radius. So if I use the distance formula to calculate that distance, or to graph it, and if it's a horizontal or vertical line, just count the grid marks between it to find that distance will be my radius. Okay? So they use the distance formula, so negative 3 to 1 is 4, and negative 2 to negative 2 is 0. So you're going to get 4 squared plus 0 squared. Square root of 16, so you get 4 units. And honestly, if you plotted these points, guys, left 3 down 2, right 1 down 2, you can count horizontally that they're 4 apart. So now I know my radius is 4, I've got my h and k, I'm good to go. Okay, so x minus negative 3 is going to become x plus 3, y minus negative 2 is going to become y plus 2, and then of course 4 squared, so you're going to get 16 on the right side. Okay? All right, why don't you give this one a shot? Similar. Center's at negative 1, 0, passes through the point 3, 0. So, there's your h and your k. Let's talk about r. Okay, negative 1, 0, left 1 up 0, 3, 0. Okay, that's a horizontal distance again of 4. You could use the distance formula if you didn't have that recognition of how it showed up in a graph. X minus a negative 1, so x plus 1 quantity squared, so it can't be these minuses. And y minus 0 squared, so it's going to be plus y squared, and then equals 4 squared, or 16, looks like A. Okay? All right, this one's gonna take us a little bit of effort here. We gotta complete the square to get it in that format, x minus h quantity squared. We did this back in Algebra 2. Completing the square was one way to solve a quadratic, okay? So what I would do, as I'm doing this, is I would put the constant on the right side of the equal sign, which it already is, and then I would group the x's together and the y's together. And I would leave a blank right here, you guys, so I can complete the square. So over here, you take half the middle term and square it. So half of 4 is 2, squared is 4. But because I added a 4 to the left side, I need to add a 4 to the right side so that I don't unbalance the equation. And then I need to complete the square for y as well. So if I focus on just the y's, half of 6 is 3, squared is 9. I added a 9 to the left side, I have to add a 9 to the right side. So this becomes x minus 2 quantity squared. I made it a perfect square, I completed the square. This is y plus 3 quantity squared. And then the right side, if you add all that together, is just 4, and that's the standard equation of a circle. And so they want me to graph it now. Well, my center is going to be at 2, negative 3, so I should put a dot there. And my radius is 2, okay? So when you look at your graph here, 2, negative 3, radius of 2, stretch out. If you have a compass, stretch it out. If you don't have a compass, just go 2 left, 2 right, 2 up, 2 down, and freehand a circle as best you can, okay? All right, why don't you guys give this a shot? All right, so there are no other terms with x squared, so I'm going to leave that one. And then I've got y squared minus 10y, and then equals 0. We need to complete the square with the y's. I don't have an x term, so I don't need to complete it with the x's, but the y's. Half of 10 is 5, squared is 25. So I need to add that 25 to both sides of this equal sign to keep it balanced. The left side then becomes x squared, and this is now a perfect square. This is y minus 5, quantity squared, and I get a 25 on the right side. All right, so the center of my circle is at 0, because that's x minus 0 quantity squared, and 5, because I have y minus 5 quantity squared, and my radius is the square root of 25 or 5. So I'm looking for the one that has the circle centered at 0, 5. Well, that's centered at 0, 0. That's 0, negative 5, and that's 5, 0. This is the only one that's centered at 0, 5, with a radius of 5. Okay? So a little bit of algebra to get it in the format that I need, and then the graph isn't too bad after that. Okay? This example here we're going to skip. We're not going to see one like it in the assignment or the test. Okay? So we're just going to move on with this one, you guys. Okay, what about this one? Find the points of intersection between these two. So you could do this two ways. If you have graph paper, you could graph a circle that's centered at 0, 0 with a radius the square root of 32. And you could graph this line, y equals x plus 8. You could find out where they cross. And those ordered pairs are your solutions. Algebraically, we could take this x plus 8 because it's equal to y, and we could replace that y with an x plus 8 and then solve, okay? So we're going to see both. So if I graph these, here's my circle, centered at 0, 0, radius square root of 32, which is, 5 point something. And then there's this y equals x plus 8. It looks like it touches just once at negative 4, 4. Okay? Second way is to replace that y with an x plus 8, and we're going to see that next. Okay? All right, so if I square that, now you got to remember this, guys. We've done this before, but this is going to be x squared plus 16x, because you have to take x times 8 and double it, plus 64. Okay? Simplify the left side, 2x squared plus 16x plus 64. You might even subtract the 32 to get a 0 on one side. I can divide everything by 2. And then this is x plus 4 quantity squared if I factor it. And so x becomes negative 4, okay, just like we saw in the other example. And then y was equal to x plus 8, right? So if I plug that negative 4 in there, negative 4 plus 8 is 4. And that's what they're going to do next here. Okay, we knew y was equal to x plus 8, so I can put a negative 4 in because now I know x. And so y must be 4, and we've got algebraically our equation there. Okay? All right, give this a shot, you guys. Okay, graphically, if you're going to do this, you would have a circle centered at 0, 0 with a radius of the square root of 8. And so you could sketch that. And then y equals negative x is a line with a slope of -1 and a y-intercept of 0, and you can see where they cross. I'm going to do it algebraically for you, though. We know y equals negative x, so I'm going to replace that y with a negative x. And we're going to go x squared plus negative x quantity squared equals 8. So x squared plus x squared is 2x squared. Divide by 2. And so now x can be plus or minus 2, and I need to take both into account on this case, okay? If x is negative 2, put it back into this equation, the opposite of negative 2 is 2, so that's one solution. If x is positive 2, the opposite of 2 is negative 2, that's another solution. So there's going to be two scenarios here, and they're both listed right there. Okay, so this, there's the algebraic way, graphing it, you could take care of that as well. Okay, and there's your assignment, you guys, page 760, 13 to 35 odds. Tomorrow we'll review, and so if you show up in the Google meeting, we'll talk about what's going to be on the test and answer some questions. Good luck, you guys.